All right, today we're going to talk about functions and what that means. We're going to get into that for the 8th grade material. A function is something is like a machine. Okay, so a function is very similar to a machine. You're inputting information and you're getting out information. So we can do this with numbers. We can look at this a few different ways. We can look at it as a table. We can look at it as ordered pairs. We can look at it as a graph. And so as we get more and more into this, we look at linear functions in 8th grade. And for Algebra 1, you look at many different functions. You have step functions, you have absolute value functions, you have quadratic functions, and all those things. But we're just going to look at the very basic introduction of a function. So a function is literally a machine, and we're going to put numbers into it. So if it is a process, and so one of the things you always see is a input output. Okay, imagine this was like a bubblegum machine. If you put 25 cents in and you crank it and you get a bubblegum out. Okay, so you expect to get that result. Every time you put 25 cents in, you get a bubblegum. But let's say you put 25 cents in the next time and you get something totally different and you weren't expecting bubblegum. That doesn't make sense. It didn't function the way it was supposed to do. So the same thing here with numbers. So like, for example, if we put input 1 into this machine, and maybe this is, times 3, and we get out 3. Well, we plug in 2, and we plug it in there, and it goes through, and we get 6. And so forth. We plug in 3, and we plug it in there, and it comes out 9. Well, right now it's functioning. Okay, it's functioning just fine. You plug something in, you get something out, and it may sometimes even be the exact same number. Okay, but every input has its own output. That's a key thing right here. Every input has its own and only one output. Okay, now the outputs can all be the same. That's all right, but every single input has its own output. That's a very important key thing to understand here. And so what happens though is if let's say this function machine and I plug in number 2 here again, and it's supposed to be times 3, right? So I plug 2 in again, but this time instead of getting 6, I get 7. That doesn't make sense. We know 2 plus 2 doesn't equal 5. It equals 4, right? Well, I plug in 2, and this time I get 7. There's something wrong here. There's a function. It's not working correctly. Okay. Same thing kind of happens with your calculator when, or a computer, and something doesn't go right. It's not functioning correctly. The command, something has been corrupted. Something has not worked correctly, or something in the code is not where it's supposed to be. Something has been interchanged with what it's supposed to be in the programming. So you have a function that no longer functions. And when you input a value, something else comes out. So you press the S key on your computer and you're supposed to get typing S. Well, now it's typing something totally different, or it's crashing your computer. There is a problem with your function. And so we're going to look at that as far as math is concerned, comparing it to tables, order pairs, and graphs. So in a table, so we have an input-output table. I'm going to put the variable x there because we often use x and y for our inputs and outputs. So our input is usually what we're putting in and what we're getting out. And same thing like in science where you're talking about independent and dependent variables and what you're plugging in there and you're trying to figure out information. That also happens in science where you're making a graph. So if we input a number, we get 3, we get 7. We put 4, we get 7. 5, we get 7. 6, we get 7. Now remember, there was a key phrase here. I said every input has its own output. This right here, we have 3 right here. Can't really see that very well. This is a function. It functions just fine because you plug in 3, you get 7. You plug in 4, you get 7. 5, you get 7. 6, you get 7. And let's say we plug in 3 again and we get 7. That's okay. As long as we always plug in 3, we get 7, no matter what. Now, if we plug in 3 again and we get 8, that does not work. That is not good. All right. That does not work. It's not a function. It does not work well at all for us. Okay. So that doesn't work at all because we're getting a different outcome and we don't want that outcome. And it doesn't matter if all of them are the exact same. It does not matter. Now, remember, an input-output table is also the same thing as a quarter or as an ordered pair. So ordered pairs are your x, y's. And when you graph the little point on the graph on the XY chart, that is an ordered pair. This is actually an ordered pair. 3, 7 looks like that. 4, 7, 5, 7, 6, 7, 3, 7, and then 3, 8. But remember, this is still not a function because once we can plug in 3 the third time, it comes out totally different. Now, if we erase that and get rid of the 3, 8, not there, that's okay. That's fine. It's now a function. It works just fine. Every input has its own output, and we're good there. All right. So remember, ordered pairs are just a point on a XY graph. So if we were to graph these, and we make a Cartesian plane here, so X, Y, and I'm not going to be super accurate with this because I'm just drawing on the whiteboard here. Let's say this is 3 right here, so 3, 7. Let's say this is 7. And so this is the y-axis, and so 3, 7 would be here, 4, 7 would be here, 5, 7 would be here, 6, 7, and 3, 7 again, right with the same dot. Now, you see this line, if we connected the dots, would make a horizontal line. So there is something called a vertical line test, okay? So a vertical line test you can use, and if you draw a vertical line, I usually use dots, okay? If I draw a vertical line across that line, I only cross it once. That's good because it's saying I have every input has only one output. So every input has only one output. We're good there, okay? So we keep on doing that. All right, there's only one output for every input. So what if we come across something else? Maybe something that looks, not a linear function. Maybe it's a quadratic. So we have a quadratic like this, all right? So it's moved up a little bit, slide it a little bit. So we have a quadratic, and we do the vertical line test, and every single time we go down, we only cross that thing one time. That's fine. It's good. It's a function. It works well. It has every input has one output, and we're fine there. We're good. What if, though, we come across something? Let's erase that again and kind of make it again. What if we come across something like this? So a quadratic has been a little bit construed, translated with here, rotated. And we come down here. Now, you're like, well, that one's fine, but this one, we crossed twice. And so since we crossed twice there, this is not a function. This is not something we would input into values. The input values have 2 answers. We don't want 2 answers on this one because it doesn't work, okay? So that function does not work. It is not a function that will work for us.